Okay, so I want to go over pages 16 through 18 first. Kind of, since it's been a weekend, remind you what you're doing on these and so on. So we first start, so open up your packet to page 16. And here on this problem, we've got the chocolate chips, the number of chocolate chips in 18-ounce bags of Chips Ahoy. So I actually really looked this information up, and this was a study by the U.S. Air Force Academy. So that'd be something fun to do. So we had a mean of 1262 and a standard deviation of 118. Well, what's the probability? So whenever we're getting probability, we're going to end up norm CDFing this, where we're going to norm CDF between two z-scores. We want to go between the 1000 and the 1400. So you got a z-score for the lower value of x value of 1000, and then you got a z-score for the upper value of 1400. And after you got those two z-scores, then you norm CDF'd from, since it's that area in between, from negative 2.22 up to positive, so this area in between, then your z-scores are the negative 2.22 and the positive 1.17. So that gave 0.8658, so 86.58%. Okay, next. This one wanted to know about fewer than 1200. Okay, so if I was to look at a picture of what this looks like, once we find our z-score, then we want to go fewer than. Okay, so there's our area. So our z-score for the x value of 1200 is negative 0.53. So when I norm CDF, I'm going to go from the low z-score of negative infinity, so negative 99, up to negative 0.53, and that is 29.81%. All right? Next. So we want the proportion that contains more than 1500, so that makes our area going from the 1500 out to positive infinity. So we're going to get this upper area of more than. So our x value is 1500. Our z-score ends up being 2.02. So I norm CDF from that z-score of 2.02 out to positive infinity, and that gives me it looks like 17%. So that means 2.27% or 2.17% of all of the bags will contain more than 1500 chips. Okay, so think in context of what these items are saying. All right, and like, for example, the first one says that 86.58% of all of the bags will have between 1000 and 1400 chips. Okay, so that's, the probability of you picking a bag with that many in them. Now, part D is asking if what percentile the bag is if it contains 1100 chips. Well, you remember when we talked about if you were in the 95th percentile, then you are taller than 95% of your peers. So that means I need to know what area is below this location. So I need to know this area below. That is how you get the percentile. So the x value is your 1100, and then we've got negative 1.37 as your z-score. So the area below is from negative infinity z-score up to this negative 1.37. That's 0.085. So that makes it in the 9th percentile. Okay, so you have less than 10% chance of having 11,000 or less Chips Ahoy or chips in your bag. Okay, so now we're talking about the length of human pregnancies. So we've got our 266 days as our mean, our standard deviation 1600, more than 270. So that is our x value. Going more than, we get this, notice this z-score of 0.25 is just a little bit above the mean. not even a whole standard deviation above the mean, so just a little bit above the mean. We want to know this area. So if even before I start computing it, I'm thinking in my mind, oh, that's just a little above the mean, so it's probably going to be somewhere near 50%, because if this is your mean right here, just a little bit above it is going to be close to 50%. And here we go. So I'm going to go from 0.25 to 99. I got 40.13. So not majorly close, but that kind of does give me a guideline. The reason it is still 10% off is because, you know, this area is so tall. So there's a lot of information right there in that section. So 40% of pregnancies last more than 270 days. What percent of pregnancies last between 240 and 280? So we have to get two z-scores. We get one for 240, we get one for 280, and we want to find that area in between there. So from negative 1.63 to positive 0.88 ends up being, looks like 75.9% of pregnancies. So about 76% of pregnancies last between 240 and 280 days. And then here's this part C, more than 285 days. So that's our X value. We're going to norm CDF from 1.19 up to 99, and I got 11.7% of days. And then our last one says, a very preterm baby is one whose gestation period is less than 224 days. Are very preterm babies unusual? Okay, so I need to know how likely is it for you to have a very preterm baby. So I can either come up with the probability, but we also know our outlier boundaries would be more than 2 standard deviations below the mean. So that's what I'm looking for. Is 224 days more than 2 standard deviations below the mean? So that is what our z-score is, guys. So let's remember that a z-score is that number of standard deviations that you are below the mean. When I come up with that, it is negative 2.63, of course the negative indicating below the mean. So yes, this is a very unusual event because it is over 2 standard deviations below the mean. All right, so there's your page 16. Now, when we get here to the next page, pages 17 and 18, they're not necessarily so much word problems. They're pretty straightforward. So let's take a look at those real quickly, let you check them. Of course, hopefully you've already gotten your stamp for those. I know a lot of you did get that done on Friday, so that was good. All right, so the first one, going less than 40. So we are norm CDF, oh, it looks like I didn't even, oh, there we go. Norm CDF from negative 99 to 2.5 is 99.3, I think it ended up being 38%. All right, number 2, greater than 21. So 21 was my z-score. And, or no, 21 was my X value. My z-score, negative 2.25. I'm going to go greater than. So even though my z-score is all the way down here, I need to go greater than, above. So I'm going to norm CDF from negative 2.25 to 99. That is 98.78%. This next one is in between 30 and 35. So I've got a z-score for 30. Notice it is 0. Why is the z-score for 30 0? Okay, this is important, and I don't want you guys to just run through numbers. I want you to stop and think about what's happening. And I had gotten a question on Friday about that. Well, 30 is the mean. And what do you know about the z-score for the mean? It is 0. So therefore, that's why 30 is a z-score of 0. Okay? So I need you kind of, not getting so caught up in the numbers, but thinking about what this really means. That's what's so important about this class. So next, our z-score was 1.25. So the area between those two was 39.44%. All right. Here we go on number 2. We've got, I'll just kind of run through those really quickly. We ended up with a z-score of 1. We wanted to know greater than 10. So norm CDF from 1 to 99 is 15.87%. You could also just set it 16% because if you think about one of the other things we've done. All right, here we wanted to know between 50 and 70. So that means I needed to find the z-score for both the 50 and the 70. And once again, notice that 50 is the same value as the mean. So therefore, its z-score is 0. 70 gives a z-score of 1.33. And so if I come here to my norm CDF from 0 to 1.33, 40.82% is our answer on that. Okay, moving on to page 18. Similar stuff, going in between 4.98 and 5.2. So you have got 2 z-scores to get, and then you norm CDF from -1 to +1. That's about 68.27%. What's the probability that the length of this component is between 4.96 and 5.04? This is 2 standard deviations down. Now, I'm going to tell you that if you had stopped and thought about doing this, recall that from -1 to +1, there is 68%. Well, that's just rounded. Technically, it is this. But if you had recognized that and said, within 1 standard deviation is 68%. Likewise, within 2 standard deviations is 95%, and you didn't even norm CDF this problem. You just straight up recognized that it was 2 standard deviations down to 2 standard deviations up, and you put 95%. That's great. Okay. By the way, I see I didn't show the work on this part B. It's just the x minus the mean over the standard deviation. Okay. Which, by the way, okay. All right, number 5. The length of life of an instrument produced by a machine. Okay, so we got the mean of 12 months, standard deviation of 2. And so same thing, guys. You know, now that you've gotten into the repetition of this, you're noticing this one was going less than 7. So we z-scored that. We got -2.5. So we norm CDF from -99 to -2.5. And you get a very small number. So, that might have come up in scientific notation in your calculator, by the way. I don't know if it did, but sometimes you guys have been getting something weird and you're asking me about it. If you get something strange, I want you to look to the end and see if it has a negative exponent. Okay, because this happens a couple of times, I think even in the next page that you're going to do today. So where we've got a negative exponent. And so then you're just going to have to, if you recall from science, move your decimal, make it bigger 3 spots. Okay, so that was 0.0062, which then I moved the decimal twice, and then that made it 0.62%. All right, and then B between 7, so z-score for 7 months, z-score for 12 months. It looks as though I'm not even doing the work on those, but I did notice that 12 months is the mean, so I automatically know that that z-score is 0, and so I'm norm CDF from, so I actually don't like that I didn't show the work. So just FYI, I should have shown the work. Again, your work that you have to show is this z-score formula, that you're doing, and then your answer in a percent format. Okay? All right, I think that is all of the assignment that you've gotten stamped for from Friday that you did, pages 16 through 18. So now what you're going to do is today you're going to do pages 19 and 20. So let me actually talk to you a little bit about these before you get started. All right, so first I want to take a moment and let's read this problem and kind of think through how we're going to start this one. So number 1 on page 19, okay, because today you're going to be doing pages 19 and 20. All right, in a city, it is estimated that the maximum temperature in June is normally distributed, okay, with a mean of 23 degrees and a standard deviation of 5 degrees. Okay? Calculate the number of days in this month in which it is expected to reach a maximum between 21 degrees and 27 degrees. So what type values do you think those are, the 21 and the 27? Okay, those are both the x values. So that means we would need to get z-scores for both of those. Okay, so take a moment and do that. I'm going to pause for a second and let you do that. Okay, so make sure that, let's stop for just a moment. Pause, if you hadn't paused this, you need to, so you have time to absorb, doing that computing. Okay, so I got a z-score for 21, which was negative 0.4. Okay, I got a z-score for 27, which was positive 0.8. All right, and then I went ahead and I got that area in between those, because that's what we are used to doing, is getting that area in between those. Norm CDF from the negative 0.4 to 0.8 is 44.4436. So that means 44.36% of the days in June have those temperatures of maximum temperature between 21 and 27. And I'm going to imagine that these are Celsius or something, because those certainly are not Fahrenheit degrees. All right, 44% of the days. All right, and that's fine. And you will certainly be tempted to stop there, because in the past, all of our questions have been, what proportion of June, or what's the probability that a day will be between 21 and 27, and those kinds of things. Well, this problem asks something a little bit different. This problem takes it further, and it says, calculate the number of days in this month. Calculate the number of days in this month. Okay, so that means that not only are we, have to find what percent is in between this temperature here and this temperature here. So 44% of June has temperatures between those 2 days. I need to know how many days that is. Well, I know that June has 30 days in it. Okay, so if I get 44.36% of 30 days. Okay, and you mathematically can do that a few different ways. So let's talk about that real quick. Okay, so if you remember from math, you can do like 44.36% equals how many days out of the month of 30. Okay. You also can, I just take my number as a decimal that I had before, and I multiply that by my 30. These are both the same thing. And these are both going to give you the same results. This is multiply. Okay, multiply that times 30. Okay, and in both of these cases, we get really close to 13. Okay, so that tells me then that 13 days of June, so 13 about I do little squigglies because it came out to be like 13.03 or something. So about 13 days have will have temperatures between 21 degrees and 27 degrees. All right, so that's the final of how to do that. These next ones will be similar, however. How many students? Well, once you get a percent, find out how many students of the 500 college students. So just like you had taken it to the next level up here, take it to the next level in number 2 and find out what, the percent of those 500 college students is how many college students. All right? Okay, so then I'm going to leave you on that. Now, I do need to tell you there are a couple of problems on page 20 that I want you to omit. So let's turn to that. So on page 20, the first one says exactly 64 kilograms. I don't know why I put that in there. That's a mess up because with our normal model, we never do the exactly this only. We never do exactly. So I don't know why I put that in there. And then it turns out that E is a repeat question. It's the same as C on the previous page. So you can cross out part D and E. And then there is another one down here, number 4B. Number 4B, I want you to omit because this actually is quite involved, and we have a whole entire lesson involved in discussing this type of question. So that one, omit it. We're going to get to that kind of thing later. All right, so should have enough time to finish in class these pages 19 and 20. And then those are due tomorrow on Tuesday, and those will get stamped as well.